Assalamu alaikum wa rahmatullahi wa barakatuh. I'm sure everyone knows one of the most widely used fuel sources in the world, coal. It's been used for many, many years in the past, and even now, coal is used to power electric plants, smelt iron ores, and fuel furnaces in factories. However, this is not sustainable for the future. And so, researchers have pulled together an alternative for this fuel source, which is called biomass. Biomass comes from organic matter. Basically, almost anything that comes from plants or animals can technically be used as fuels. Not only is this sustainable, it can also help solve organic waste issues that some places have and help provide cheaper and cleaner energy to everyone. Even so, its weakness lies in its low calorie content per weight, or in other words, a large amount of biomass is needed to match the energy levels of fossil fuels. So, what's the solution? We turn to biocokes, which was first created by Dr. Tamio Ida in Japan. Biocokes are basically a more compressed and efficient version of biomass. However, it still can't compare to coal in terms of energy per weight and density. And this is the current issue that we have with biomass and biocokes till today. One method to improve this material is to find a more better biomass source with higher calorie content. This would improve the final product's energy output. We believe that oleaginous microalgae holds significant promise, as this microalgae contains a lot of lipids. Lipids are like the fat of a plant. They have a large energy content. And in fact, lipids are already being used in creating biofuels such as biodiesel or ethanol. So why use this algae as a biocoke instead of biofuel? This is due to the difference in processing, where biofuels require those lipids to be extracted from the plant. On the other hand, biocokes use the entire organism as its base, with not as much pretreatment or processing. The possibility is there. However, based on our research, there have been very few reports specifically discussing this material. In particular, specific calorie value and strength of the biocoke produced needs to be researched in order to prove this possibility. This brings us to this research. The main objective of this research is to determine the properties of the biocoke produced with oleaginous microalgae. The usual methods of biocoke production will be used, where first the microalgae will undergo pre-treatment where it will be dried and processed into a fine powder. Next, the samples will be heated under pressure for a set period of time. After samples have been produced, the caloric content and tensile strength or brittleness will be tested to see whether it is suitable as a commercial biomass source. Different compositions will be tested, where the oleaginous microalgae will be mixed with other biomass, such as wood chips, to allow comparisons to be made. There are three strains of algae that will be considered: marine diatoms, Nanochloropsis, and Aurantiochytrium. With this research, future applications involving the use of oleaginous microalgae will have a basis and a set of reference values that can be used, particularly for researchers or applications that require specific properties of oleaginous algae for other applications or in applications of biocoke in the future. And with that, I'll end my presentation here. Thank you very much.